Hi, everyone. This is Alan Schimmel, CEO, founder of MeteorOps, editor-in-chief of DevOps.com, Security Boulevard, and Container Journal. Thanks for joining us on this session in our Secure Coding virtual event, co-produced and hosted with our friends at WhiteSource. In this panel, we're going to be discussing secure coding and vulnerabilities. Before we start, though, let me introduce you to our panel members, because I think we've assembled really just an all-star panel of folks. I'm going to start with Dr. Philip Culp. Phil, if you could raise your hand so they know who you are. And Philip, why don't you give us a little bit of your background?
Sure. My name is Dr. Phil Culp. My doctorate is in cybersecurity, where I did active defense, attacking. So I think it helps in this kind of discussion. I also do development a little bit and secure source code review. So it's kind of all of my different areas kind of wrapped in one. I think can help some in this discussion.
Absolutely. Our next panelist is Dr. Nikki Robinson, and Nikki, I'm going to let you introduce yourself as well.
Hey, great, thank you. So yes, I'm Dr. Nikki Robinson. I also have a doctorate in cybersecurity. My main focus is on vulnerability and risk management, and also helping with some secure code development. So that definitely helps and relates to this panel here.
Absolutely, and thanks for joining us. And our third panel member, certainly not least, though. Look, Ken, I got to be honest. We don't have that PhD there, but nevertheless, a cybersecurity expert, Ken Underhill. Ken, welcome. You want to give us your background?
Hey everyone. Yes, so I don't have a doctorate in cybersecurity. I have a master's though in cybersecurity. Worked as a pen tester in the past, and currently the master instructor over at Cybrary, which many people in the industry probably know about.
Absolutely, and no slight intended. You know, it's nice to have a PhD, but it's nice to have some real world experience, and I don't think anyone's going to question your credentials, Ken. So guys, the subject matter is secure coding and vulnerabilities. And I got to tell you, as someone who's been in the security industry for 20 years, it kind of does my heart good that, you know, we're finally at the point where the idea of scanning code pre-deployment, as we're developing it, as we're checking it into a repository, as it's being, you know, combined in the CI/CD process, is a heck of a lot better than when we were 15 years ago or 20 years ago when I first got into information security. However, it's far from perfect, right? I think we'd all agree on that. Our audience tends to be rather technical on these virtual events, so I didn't want to do a 101 type of panel, but why don't we at least start though with like an OWASP top 10 kind of discussion, and you know how that has been changing and evolving in given times, and all three of you know it cold. Who would like to begin our discussion?
Well, I can go ahead.
Yeah.
I can go ahead and get started. So on OWASP top 10, you know, one of the big things we talk about is secure configuration, and it's really at every layer of the OSI model and secure development. It's not just, you know, for servers and for patches, but it's also for secure code development. So that includes everything from obviously running the latest version in your frameworks and your servers, but also restricting web servers, processes to use that least privilege. So there's a number of different components when we're talking about secure configuration and when we're trying to develop secure code from the ground up.
Absolutely. Gentlemen, would you like to add to that?
Sure, I'll just chime in. I think configuration is definitely something we need to address. Going along the lines of the OWASP top 10, one thing we've also seen on there, pretty much every time OWASP has come out with it, is the injection attacks, right? So we're talking about SQL injection primarily that we're seeing out there. So I think just going along the lines of configuring our code properly, we can help mitigate some of those things. So I just wanted to interject that part.
Yeah. Phil, Dr. Phil, anything to add?
Sure. I kind of won't reiterate what they said about the OWASP Top 10, but I can kind of look at so there's another tool called the OWASP Threat Dragon, which you can actually take your applications and say, here's where my database is, here's the boundary between the database, the application. And I think that's also useful, is to use that threat modeling and say, here's what specifically is going to impact, maybe I'm in the healthcare industry or anything like that, and look at that. And then when you go to look for what tools, what attacks you're looking at, you can map it specific to your organization as well.
Sure. So, wanted to dig in a little bit. Dr. Nikki, you talked about configuration as an issue, and really, one of the early kind of drawers for the whole DevOps movement were configuration management tools like Chef and Puppet and Ansible and Salt, and of course, to a certain extent, a lot of that now, a lot of the heavy lifting around configuration is being uptaken by Kubernetes, right, in containerized and serverless environments. But really, the point there is that, the idea of having sort of a copy of your configuration would hopefully make our configuration issues go away. Why hasn't it? Or maybe it has. I'll throw it up to all three of you.
I can hop in here first. I think it's very similar to what we're seeing in DevSecOps, similarly to what we see when someone's trying to build a baseline for a Windows 10 or Server 2019 baseline. It's very difficult to add every single security component to that at the beginning, and then even as you're going through stages, it can be difficult when you're trying to push a product out, push your code out. It can be really difficult to say, we've got to add extra time here, or we need to do this, we need to do that. As you're trying to go through the process. So it adds complexity sometimes into that pipeline, which can slow down projects, and no one wants to do that. So I think it's just difficult to get to that point. I think once we get to that point, it'll make secure code a lot easier on developers and the security teams. But we're just still getting there.
Absolutely. Anybody else?
Yeah, I was going to say, I kind of come off what Dr. Robinson said was that I think it's really difficult, and it's a maturity process to, if you want to read in deep into like, you should be doing infrastructure as a code, and you can use using Puppet, like you said, Ansible, and you start getting overloaded with these terms, and especially when you start reading and saying you should have a blue, green deployment environment, everything should be code. It sounds great. It's very difficult to do in practice, especially when you're trying to move from that model where we try to fix things in production. And if you look at, say, Netflix, where they're like, we don't touch production. Everything's infrastructure as a code. Everything gets deployed. And so it's really just trying to, like I said, getting people to look at it as a maturity process. Say, like, here's the steps I can go to get, maybe if I want to get to that point. It's just difficult, 0 to complete, everything is in production. We don't touch it.
Yeah, and my commentary is really similar to Nikki and Phil's. It's just the complexity of it right now. And I think Phil had made a good point there of we need to look at it as a maturity process and not just, I need to do all these things right now. I think people get overwhelmed with what they need to do.
I agree. So I wanted to, moving off that onto another topic, I want to talk a little bit about what's become known as SCA, Software Composition Analysis. Right, and to me, this the term SCA, I guess, was coined by Forrester, I think. But really, what it's about is it's looking at today's applications are somewhat Frankensteinish in that they're made up of different components, maybe snippets or components of pre-written code that do different functionalities, and then sort of glued together. But the fact is, many of our applications today are 75, 85% open source components and snippets, and only about 15, 20% custom code. And so the idea of testing these components that make up the bulk of our applications is really kind of what SCA is about. If that's not what it is, I'll ask any of you to give me your definition, but it's given rise to this whole open source testing, which is a subset of kind of secure coding.
Yeah, so I'll just jump in there real quick. Yeah, so you're accurate with that, Alan. It's basically going to allow you to manage that open source code, and that's really the purpose of the SCA tool. So you can get visibility into it for your code.
So, Ken, in your mind, though, is SCA just open source code, or is it all kind of pre-configured, pre-packaged components?
I think a primary use is going to be open source code, but it can be used for pre-configured packets as well.
Okay, and then, so, look, the Struts and Equifax situation is probably the poster child for SCA, but that, people get a false sense, I think, when they see that. The fact of the matter is, yeah, that is the poster child. It's out there, but we see every single day open source vulnerabilities being reported, found, and people still using them. I'd be interested. Does any three of you have any kind of facts, figures, sense of how many open source vulnerabilities are found each week, month, day, year, or what have you? And, because there's a reason why we want to do SCA continuously.
Yeah, I don't have specific facts on that, but the mindset should always be that there's always someone out there trying to attack your code. So if you're not continuously making it a process that you're going through to analyze for vulnerabilities, then you're just setting yourself up to be breached.
Yep.
Well, and I can hop in here too, because I think it's difficult to get accurate numbers on how many, number one, vulnerabilities are actually out there, and number two, how many breaches have actually occurred because of poor security practices in coding, because a number of breaches aren't reported in the media or for any of us to find, and vulnerabilities come out so frequently. It's very difficult for us to keep track of everything and to also figure out how that relates to what people are attacking. And as Dr. Culp mentioned earlier, adding threat modeling to secure code development really helps to mature that process, because using those threat modeling techniques, you can start to figure out, well, who's targeting me? Because I don't need to know every vulnerability, but if I can figure out who's actually targeting me and why they're targeting me, I can focus on those secure configurations and upgrades and patches that matter to me and my business.
Yeah, so there's a couple different levels to this, and there's a lot of nice open source tools out there that can check whether you're doing Java, .NET, and it'll just take your configuration file, whether it's POM, XML, whatever, and say, okay, let me go pull it from the NVD database. I see what version you're running, and I can then check and map it against the vulnerabilities and do it that way. But I think the fundamental issue is that we, the community and the developers, everybody hasn't got used to patching systems the way, and patching software the same way we do systems. It's I'm developing a code. I need this functionality to do whatever. I go and get it. Cool, it works. Now let me, make the rest of the application work, and I don't have to use it anymore because that's thought of as functionality. Whereas we're having these vulnerabilities that are coming out, and we're not into that life cycle of testing them and continuously testing it, because it's difficult to test it, make sure the functionality works that way. And then it also goes on to say Docker images. You might be used to just saying like, oh, I need this container that does this. Cool, let me do this. I don't check it because I don't know what I don't need to check what it does. I just need this functionality for my microservice, and let me get that working. And part of also too, again, is it's open source a little bit, but we're used to say, even when you're using Python, I don't have time to go through all these dependent these libraries. I do pip install recursive, and it just installs everything. Cool, it's working. Let me move on. I didn't pay attention that this one installed this one, which installed this hierarchy, and suddenly I have 30 packages all to make my one little thing work. So it's difficult that way as well.
Absolutely is. But, this is a bigger issue, I think, in security, in that, we do the things we're comfortable with, and it gives us a false sense of security. As Nikki, you've alluded to, we could scan till the cows come home and just continuously keep scanning and continuously keep generating a nice long list of vulnerabilities. That it's kind of job security, right? It keeps us busy with that stuff. But is it fundamentally changing the equation around security? And Dr. Phil is no pun, Dr. Phil. I'm sorry to say that, but Dr. Phil is okay, but Dr. Phil, as you say, you know, there's got to be somewhat of a better way, right? How can we, you know, stop the insanity of just scan, fix, you know, rinse, repeat, and get more into understanding what our priorities are, what our pathways are, and so forth.
Sorry to just jump in. There's also tools you can put directly into the IDE. So as they're typing, I'm sorry, there's a Chrome browser extension where when the developer's actually going out to look code, it'll say like, hey, you might be looking at the wrong version here, or you might have a vulnerability. So we can kind of push that as left as far as possible, and then work on the policies of how do you update versions and things like that as well.
And that's important, and I think the important thing that we need to note for that is these are tools that are developer friendly, right? The average developer is not going to look at your normal vulnerability scan readout and see where they're mapped to CVEs and say, oh, okay, I better prioritize this one, that one, there's a higher one. I think developers need helpful tools like that are geared for what they're doing, what their level is, and where they want to be, you know, and what they're working on. But I want to move over now to kind of different kinds of scanning and testing that we see in the secure coding world. And primarily I wanted to kind of hit 2, maybe 3 categories, you know, DAST, D-A-S, right? SAST, so dynamic scanning, static testing, and then there's IAST. And I'm drawing a blank this moment. Ken, IAST stands for?
I'm drawing the same blank, but yeah, Phil, you want to grab it?
Interactive, something like that. So let's start with this. Which one of my panel members wants to just give us, our audience, a quick kind of overview? What's DAST versus SAST versus IAST? IAST, whatever.
So I'll do it, and I'll preface this by saying I'm not a secure coder. I'm not a software developer. I mean, I write in Python, but it's mostly malware and stuff. So I'm going to preface it with that. So don't hate me out there in the audience. But basically, your SAST, right? Your static analysis. We're looking at the code itself, but we don't see it as it's executing. So we're just kind of looking at the actual code base itself. The DAST is going to be your dynamic analysis. So as it's actually running, but normally that's going to be after the application's built. So we're kind of looking at SAST being the slowest, right? DAST being sort of after the fact, the traditional bolt on the security afterwards. And then the IAST is going to be while we're developing the code and we run it to check, hey, is this working? It's also checking for those issues in the code itself. So it's a little faster iteration throughout the process.
Nikki or Phil, any comments on that?
Well, I was just going to add that I think there's a place for all 3. And depending on what kind of code you're developing, what your timeline looks like, you know, you can integrate each of them at different stages. I mean, of course, we always want to talk about adding security first, but you can integrate them as you go. You know, especially if, let's say, you haven't built security in from the ground up, but you're halfway through your project and you're like, oh no, we may not, you know, get our ATO or get approved, or maybe we can't go to production yet. You know, you can start to add some of that other testing functionality in there, at least while you're going through, so that you're not waiting until the end to add that, you know, potentially dynamic testing. You can still do some static code analysis during your project to make sure that you're adding those security measures as you go through.
Yep. So I mean, this is kind of my fundamental thing that I always say is that it's at each one of the stages. And what I like to do is whenever we're starting a new project and I meet with the developers, and I just say, look, here's the tools I'm going to use. Here's the process I'm going to do. I will give you access to anything. Again, trying to move it as far left and as early as Nikki was mentioning, and just say like, you might be used to security people that want to find as much as possible. I don't. I'd love to not see anything. I want you to fix it and say, so here, like I said, here's the tool. And again, there's IDE tools like spot bugs or these Puma scan and things like that, where you can actually put it into the IDE, and as the developer's writing, it'll pop up and say, hey, you just wrote a SQL injection, or you just did, you know, whatever other problem that you should look at. And so we have the SaaS side again, as you kind of mentioned, is the IST, where it's running, you actually deploy it into the application server, so Tomcat, whatever, and so it's actually pulling telemetry information off of there. It doesn't do any scanning itself, but it actually, they said it can recognize attacks. And so you turn that on, and then you have the analysis engine running, and then you run your DAS tool against the application, and then the IS tool is watching these attacks from the inside and saying, hey, I just saw this data came in and went all the way to the database, and now something in the application changed state, and so I can monitor it that way. And because it's possible you ran the DAS tool and it didn't see anything, something failed because of the way it tested it, but in the internal it actually succeeded. So maybe somebody smarter doing it manually could have actually exploited that vulnerability. And then the kind of the newer one that not many people use is the RASP, which is the runtime application self-protection, which is very similar to that IS tool where it's running internally. So it can see the source code, it can see, again, the third-party libraries, all of this components. And so as attacks are coming in, or possible attacks, it can actually stop those attacks, which is kind of interesting too, in conjunction with the web application firewall. So we can kind of stop that in case there's a 0 day, some other issue. And then we have that little bit of a stopgap or measure where we're going to fix the actual problem, but we have that, a bit of a time where we can stop them before we get a chance. We don't just get completely owned in the middle of the night.
I think to add on to that a little bit, it's that trying to add that proactive approach instead of being reactive after you've already developed this code and you're like, oh, I've got to go back and update this library or do this, add this piece in my code. It's like, well, don't do that. Try to be, proactive. And if we can add those tools at the beginning, that can really help to improve security along the way. So some of those new tools I think are great and can really change the maturity level of your development process.
Yep. I think important takeaways for our audience here is some of the things you guys have hit. Number one, no one of these tools preempts the other category of tool, right? Just because you're doing DAST is not a reason not to do static code analysis or IAST. Like everything else in security, it's about defense in depth. And so we want to... there's no reason why you shouldn't do all three. I think we're all in violent agreement on that. Ken, yes?
Yep, that's oh, sorry, I was going to say that's part of the process at the beginning. Before we kind of think of DevSecOps as it's automatic tools, and that's how I fix it. There's a whole planning process at the beginning. Like I said, here's how I'm going to develop. Here's the developers. Here's the software I'm going to use. I need to plan this out. So along the way, I'm fixing vulnerabilities as early as possible, because the longer I get into the pipeline, the more expensive it is. Because then I got to go back. I got to think about it again. I got to recode it. I got to retest it. So let's find it early.
Well, it was funny. I was talking to someone earlier this week about secure development, and I said SecDevOps. And they were like, wait a minute, isn't it DevSecOps? And I said, well, yeah, but shouldn't we have security at the beginning too? Because if we're working together, security and the development team, for security to really understand those requirements, what's really needed in that project, that helps the security team to work better with the development team and say, oh, okay, I understand why you're using this functionality, or hey, why are you using this library? Or why is this functionality left over from test into production? Do you really need that service running? Or, is that really something you need in production? So that helps bring the two teams in alignment, which again helps with all of that project development, timelines, resources, budget. It kind of helps work through all of those potential issues if you get started from the beginning.
So I will tell you that could get religious on you real quick, Nikki. When we first started using the term DevSecOps 5-6 years ago, and for the last 6 years I've been putting on a DevSecOps event at RSA every year. And originally it wasn't called DevSecOps, it was called Rugged DevOps. And when we started using the term DevSecOps, we got a hell of a lot of pushback from both the DevOps community as well as the security community, because from the DevOps community point of view, the things we do in DevSecOps are really just part of good DevOps, right? This is what we do in DevOps. We shift left, we automate, we speed up, we do feedback loops and stuff like that. And why do we need to put the word sec in there other than to make these security people feel good? And the security people, much like you, Nikki, say, well, sec should go first because that means we'll do it first. And it becomes religious when it doesn't have to be. I think suffice to say is that when we're doing development and operations, we need to be thinking about security. And it's not just the security people thinking about security, it's the development, DevOps, and Ops folks thinking about security as well.
Right, right. And to add a little more context, so I come from the IT world. So I was in infrastructure and ran Citrix environments for many years before I even got into security. And so I've seen that, from the other side, from the IT operations side, working with security. And, this is something we talked about earlier, but using the same terminology, discussing the same things. So that way, when we talk to each other, it's not like, hey, I'm not here to stop your project. I just want to make sure as you're going through, that you're doing it securely, that we're making sure we're not adding a SQL injection or a cross-site scripting where we don't need to. But, our intention is never to slow down the project, but just to help, developers as they go through. And I think coming from that side of, hey, I'm here to help and I just want to make sure things are secure, can really change the conversation around development, operations, and security.
Agreed. Ken, I'm interested in your role at Cybrary, right? You're teaching a ton of people around this stuff. How many of them, are not, quote unquote security professionals, but rather maybe developers or DevOps or Ops people who just want to understand this whole security thing and how it fits into their life better?
Yeah, we actually get quite a few, not just on the dev side, but also the general IT side, even executives that have nothing to do with security or IT, and they're jumping in there as well. So I just think there's a terminology that's thrown around called security enablement, right, where we're just basically baking security into everything in the organization. So we're seeing a lot more people that are, especially with all the breaches and everything happening and being in the news all the time, people are more aware of like, okay, I need to learn this stuff. I need to learn what are the basics of security that I need to pay attention to for my day-to-day stuff. And so we are seeing an increase in that. I don't have a specific number for you, Alan, but we are seeing an increase in the number of both dev people as well as kind of across the board that are learning about security.
Excellent. So, guys, I want to pivot our conversation. We have about 15, 20 minutes at most left. I want to focus now on the vulnerabilities aspect of secure coding and vulnerabilities. And that is, we're turning up vulnerabilities certainly, right? And let's focus in on the SC, on the open source kind of vulnerable components aspect, similar to Equifax and Struts. I've seen multiple surveys now where people are still downloading the open source, the vulnerable version of Struts 2, not quite as much as they were before, but they're still downloading it. What is it going to take for us to really, why aren't we doing a better job of making sure that people aren't using an older vulnerable version of an open source component? It seems like a no-brainer to me, but it's not evidently. Thoughts, comments?
I'll just chime in real quick. I think we just go back to the fundamentals of we can't control that person's actions, right? We can train somebody, for example, like on phishing emails all day long. We can train them. But at the end of the day, if they decide they want to click that link because it seems exciting to watch some funny cat video, we can't control that aspect of it. So I think we're seeing the similar thing, right? We can preach about they should be using the updated libraries, et cetera. We should do these things. We can put policies in place. But at the end of the day, that human element is always going to be there. There's always going to be that risk factor.
Still the weakest link in the chain. Nikki?
Oh, sorry. Yeah, I was going to add, it's also, I think, when we're talking about a top-down approach for security, when you have someone in a leadership position, whether it's the CIO, CTO, or chief, data officer, anyone who might be involved in that development pipeline, if they really, come back and say, guys, we need to add security, or, let's at least think about it. What do we need to do to add security to this process? That can really, again, help to change the conversation and also change the way that they code, because if leadership or management or anyone who's running the project isn't concerned about it, they're more concerned about timelines and deadlines and making sure that the product is available for the customer, then security just may not be added in the way that it should be. So I think having that that executive, that leadership, anyone come in and say, hey, let's make sure we're not using Struts. Let's make sure we're not using Windows 7. Let's make sure we're not using these old versions of software. That can really kind of help improve security along the way.
Yeah, and I think kind of following off of what you're saying too is again, you'll keep hearing me say push left, and go even farther before that. So like I said, looking at the contracts we give to developers and say, because I've seen these before, that you have this kind of wishy-washy contract. Your code should be secure and no bugs, but what does that mean? And how do you enforce that? So maybe put some specific language in there that says you must follow Carnegie Mellon, secure coding standards, requirements, things like that, so that when the security team comes in and actually finds something, we can map it to that requirement and say, here's exactly, you did not do this, and add a little bit of teeth to it that way. But again, and part of the other issue too is, do you have security people that are the auditors that are reviewing this that really have the knowledge of development, kind of back to the language and talk, or even, there's so many languages out there. You need an expert that knows how to Java, .NET, and Python, and then there's JavaScript in the interface, and then understanding Kubernetes and the containers and all that, and having that knowledge to be able to, I hate to say combat, but be able to speak the same language and be able to talk to the developers in the operations side, and not just, here's, I got my automated tool, let me run it. It's 100 pages, here's 1,000 vulnerabilities, here you go. I just lost my credibility because I just gave them 90% false positives. And so it's really, again, that building that relationship and that expertise, and to show that you're a professional and you understand it and you talk the same language.
Excellent. So here's my take on it. And keep in mind, I'm a veteran of the IDS to IPS wars, right? I founded a company that had one of the first intrusion prevention systems rather than just intrusion detection, which means we could actively block, not just alert you to malicious traffic coming in. But what I failed to understand, and ultimately led to not this, why we weren't more successful, is that people were scared to death to block traffic in real time because they were afraid they were blocking the CEO's email or something mission critical, or maybe it was a false positive. And so they would much rather take the chance of malicious traffic coming in the network rather than automatically blocking something. Even if you don't have to block everything, but just block the obvious, right? But it's not as obvious as you think. And so I ask, why can't we have, I call it an open source firewall, if you will, right? Where when we do the scan and we see that it's an old version of a component, why can't we either automatically update that component, or if you say, wait, that's too much because that could break things, right? There's dependencies, or put up a red flag and say, hey, this is not ready. This can't be deployed. Someone has to go look and see why you haven't used the latest open source component. Why aren't we doing that versus saying, well, look, we can take the horse to water, but we can't make them drink? Which, with all due respect, Ken, is kind of what you're saying, right? Thoughts?
Yeah, and part of it is this mentality where you have to have somebody with a strong will that can say, I'm going to take this on, and I'm going to take any effects that happen to this. And kind of what Nikki was saying is push it up as high as you can. You need a champion at the top that says, this is what we're going to do, and this is what we're going to do because this is the right thing to do, and we're going to have the consequences of it. And I'll finally say, push it to the right, where we have effective continuous monitoring, where we're going to be putting in, or kind of what you were saying about that open source firewall, is these RASP tools that can do that can actually monitor, and they can look at the do software composition analysis and see you're running third-party libraries. But then let's also pull some metrics off that and see how much is being blocked. Are we doing this effectively, and is it accomplishing what we want to do?
I think to add on to what Dr. Culp said, I think, again, when you have that leadership, having a leader who is technical, or at least has people that are technical that they can trust, that they can talk to and say, is this a real concern? Where's the real concern? Someone that they can trust, or, they have the research available that they can go and say, okay, you know what? I'm not as concerned about maybe this vulnerability or this issue, but this one is a big deal, because it's customer facing, or, we've got these other issues. But having the leadership to come in and say, yes, please make sure it's secure. And two, the continuous monitoring piece, I feel like is so important, because as code continues to be developed and updated, just as you were saying, Alan, things are changing. People may pull in old libraries or maybe using other things and they're injecting it. And so having that continuous monitoring piece where you can come in and say, hey, you know what, I found this vulnerability. We didn't see it before. Was there a new code added? What happened? So having that continuous monitoring piece, I think, can help kind of control any potential issues in the future too. Because even if you're adding security at the beginning, there's always that chance that, you know, as you're adding new code, that you could be adding potential issues or vulnerabilities.
Fair enough. So, you know, what I'm hearing, though, is just like many other things, not just in security, but in DevOps in general, there's two aspects here. Number one is a tooling aspect, right? And it seems like we have the tools who could do that if that's what we decided to do. But, you know, superseding the tooling aspect is a cultural aspect where we've got to have strong leadership who will say, hey, this is how we've got to do it. We've got to have a culture of people who say, look, I realize this may delay getting my code out because I've got to update a component and then go back and test, make sure there's no dependencies that are broken, right? And that, you know, we've all dealt with developers. We know how the development time cycle works, right? Delays like that kill them. And so, again, there's a very cultural element to people understanding why it's so important, why we must use the latest versions. If you have a known open source component vulnerability, why you don't want to go to production with that. And
right.
That's...
Right. And so I think that's the two-sided conversation. So having your developers being able to have an open conversation with security and being able to understand that development, there's a process, there's a way that we have to do things. So, you know, sort of what Dr. Culp alluded to earlier, which is where we need to have the correct terminology and the ability to talk to each other. Because if we can't communicate and say, hey, from security, I'm seeing this issue, and then being able to talk to the developer and say, does this impact? How does it impact? What can we do? And kind of being able to adjust on both sides, because it's not just, you know, developers needing to change mindset, but it's also security too, understanding the terminology, making sure that when you're giving someone a recommendation that it's appropriate and you're not, like Dr. Culp said, throwing 1,000 vulnerabilities at them and just say, hey, fix all of this.
Yeah.
But just
today.
You know, yeah, right. Just fix it today. I don't care about your timeline, just fix it.
Right.
So it's part of that. We both kind of have to shift how we think about development projects.
Yeah. So guys, we have maybe 6 minutes left. I'm going to ask one last question to each of, same question to each of you, and interested in all three of you. So I'm a glass is half full kind of guy, and I think we've made real progress these last 3 or 4 years in you know, producing and deploying code that is much more secure than it has been 5 years ago and beyond that. I'm not saying we're perfect and there's a lot still to do, but I think we've made progress. I'd like to ask each of you, do you agree with that supposition, number one, or proposition? But number two, what do you think is the one or two best things we could do to take it even to the next level? And Ken, I think I introduced you last when we started, so I'm going to ask you to go first if it's okay.
Sure, absolutely. So I agree with that. I think we've made significant progress over the last few years. I think probably in my mindset, the thing that really needs to happen and continue to happen is speaking the same language, right? So Nikki alluded to that with the security and the DevOps teams, but I think adding to that, we also need to speak it to the senior leadership and have them understand from a financial impact, if we don't do these things, what's going to happen to the organization, right? How much revenue would be lost? And so going back to the tool thing real quick, if we implement this tool and the cost of this tool, how can that save us money or make us money, et cetera? So just making sure that everyone understands the conversation at the level they're at and then at the other levels they need to speak to.
Fair enough. Nikki, how about you?
Yeah, so I definitely think along the same lines. I do think things are improving, especially if, you know, people have had failed projects in the past, or they've seen in the past, oh man, we developed this code and We ended up having a SQL injection. We did end up getting breached. Learning from all those mistakes from the past, I think, has really helped people to think about security, at least while they're in development. The pieces where I think we can still improve is teaching developers security terminology and teaching security developers terminology. So making sure that everybody's having the same conversation, and that when security does come to development and say, hey, I noticed this one thing, can we fix this? That conversation is successful and helps to improve secure code development as the project goes.
Excellent. Dr. Phil, we're going to give you the last word on this one.
I guess it's time for a shameless plug, but I don't get paid for it. So I actually just finished working on a DevSecOps fundamental course for cyber. It should be published maybe a week or two or so out. So I said, where I tried to talk about all these things and kind of talk about it from a perspective of maybe you don't know anything about it, or maybe maybe how much you know is again working on a maturity model. And like you're saying, I don't know if the code's getting better, but we've got a lot more resources out there. Like if you haven't seen the DevSecOps enterprise work that the United States Air Force has done for the DoD, it's amazing. NIST is working on it. They're working with them. They're trying to get out. So on the federal side, OWASP actually has the DevSecOps, like I said, maturity model where they kind of step through each one of the process. So there's a lot out there, and I guess like I said, secure coding standards. The last component is trying to avoid vendor lock-in and maybe use more mature tools. So we have the CNCF, which is the Cloud Native Computing Foundation, where they kind of say, here's all the open source tools, and they get different levels of maturity out there. So you can pick a tool and it's open source, you can use it, and I don't get locked in, where later on development is a lot more, or have a lot more issues.
Excellent. So guys, we're about out of time. I want to thank all three of you, Nikki, Phil, and Ken, for joining us on this session. I hope our audience enjoyed. There was some good learning here, some good lessons. Of course, if you have any other questions, you can send emails, and maybe to we'll get them out to our panelists. But until then, this is Alan Schimmel from Media Ops, DevOps.com, Security Boulevard, Container Journal. Thanks for joining us on this session at Secure Coding. And stay tuned. Our next session will be coming up in just a moment.